Docker is core software that any developer should know how to use. Well, I can teach you the basics of how to use Docker to run containers and even how to build your own images from scratch. Let's not waste any time, let's dive right in. So first, what is Docker and why is it useful? Well, it's a virtualization technology that allows us to run pre-packaged environments or applications, and it standardizes the run environment. So it doesn't matter if you're running that application, that container, on Windows, Mac, Linux, wherever, it should all be identical. It's all going to be standardized, and the app is going to behave identically regardless of where it's run. I've already mentioned the words containers and images, so let's define our terms so that we're all on the same page. And luckily, there's only 3 terms you need to know. And the first is images. An image is just a collection of files and instructions that are passed around between systems. For example, you can download the HTTPD image from Docker Hub, and that has the Apache server and all of its files inside of there, along with the instructions that say, when you try to run this image, use this binary to launch the server. And term number 2 is containers. And containers are really simple. They're just a running instance of an image. So you take an image and you add things like environment variables, what ports you're going to expose for network, maybe you're running it on a Docker network, maybe you're mounting a local file system as a volume, and many other options as well. And now you have a container because it's actually running the code. And you can run that same image as many times as you want to, all at the same time with different environment variable settings or whatever other settings you want, and they're all independent, running in their own separate containers. And inside Docker, you'll find that every container has its own unique name. This way you can tell them all apart. And the third and final term is repositories. And a repository is just where we store the images in order to share or download them for Docker. The most popular repository is Docker Hub, probably because it's the default out of the box when you install Docker, and I don't even think you can override the default. So if you just type in an image name like Ubuntu or HTTPD, it's by default going to look on Docker Hub. And that's actually the repository we're going to use. So even though I'm not explicitly typing in anything about Docker Hub into the commands I'm going to show in the next steps, that's what we're using. We're using Docker Hub. Okay, so with terms out of the way, let's get into the nitty-gritty. Let's start running some commands. So the first concept you need to understand is how do you get images onto your machine and how do you manage those images? So the first command I'll show you here is Docker images. You just type that in and it's going to tell you what images have you downloaded and you currently have on your hard drive. If an image is showing up in this list, it means it's taking up hard drive space on your computer, and it also means you can run it without having to go and download it again. If you just installed Docker, you probably don't have any images yet, but let's fix that. Let's pull our very first Docker image to your computer. And the way you do that is you use Docker pull, because you're trying to pull an image. So we're going to go ahead and pull the Hello World image, which is the most basic, simplest image that Docker provides as a way to test out your Docker setup. And we're going to do that by typing in Docker pull hello-world. And then Docker will go and pull that image down to your local machine. And now if you type in Docker images again, you're going to see that the Hello World image is listed. So once you have the image on your computer, how do you run it? How do you turn that into a container? Well, again, it's a very intuitive command from Docker, and that's going to be Docker run. You're going to do Docker run and then the image name you actually want to run. So when we run this, we're going to see that it just runs some quick text and then ends. So what actually happened? What did Docker do? Well, what happened was Docker ran the image as a container using all of the defaults that the image provided, and that container ran to completion and then exited. However, because it ran as a container, it's actually still saved as a stopped container inside of Docker. And you can see what containers are running by typing in Docker container list. That'll tell you what containers are actively running. And you'll notice that the Hello World application is not running. As I mentioned, it exited. So if you add a -a to that command, it'll list all containers that you've ever run that it still has saved. And in this case, you do see that the Hello World container is listed there in a stop state. Also notice that the Hello World application has a random name because we didn't provide a name in our Docker run command. It picked one randomly and assigned it. This way, when you want to go and reference that container, it will know what you're talking about. Using this Docker container command, we can also remove containers that we don't want laying around anymore. So let's go ahead and do that as well. I don't want the hello world container anymore, so I'm going to type in Docker container rm for remove, and then the name of the container, not the name of the image, but the name of the container. Hit enter, and now that container is no longer there. And if I do a Docker container list -a again, you'll see it's gone. And just to show you how you can name your containers when you start running them, let's do one more quick example where I run hello world again, but this time I include the -- name option in the Docker run command, and that'll actually give it a name that is not randomly generated. This way, we can more easily reference it in the future. Now you'll see when I type in Docker container list -a, the name is what we set in the command line. Okay, so let's move on to something more advanced, something that is not just going to run, exit, and be done, but something that actually runs a server on your machine. In this case, we're going to do MongoDB. So a quick tip, you don't actually need to use the pull command if you're going to run something immediately afterwards. A run will automatically go and pull down an image if it's not already seen locally. So in this case, we're going to skip the Docker pull step and we're going to jump straight over to Docker run. In this case, you're going to see some new options. You already recognize the -- name. That's going to tell it that we were calling it mymongo in the container. The -e option sets environment variables that are going to be available to the application when it runs inside the container. In this case, I'm setting the username and password for the Mongo superuser. The next one, the -p, that's one you're going to use pretty often as well. And what I'm telling it there is I'm telling it what ports do I want to expose from the Docker image to my local host. By default, the application is not going to allow you to access any network ports because it's locked down. However, if you actually want to be able to access, in our case, MongoDB from localhost or from the network, you need to say that I want to expose these ports from the container that are running on the container, expose them on the running host, on your actual computer. And in this case, I want the MongoDB port, which is 27017. I want that running from the Docker container. I want it available on my host. So the left side is your actual host, and the right side is the container's exposed port. So if they were different, then for instance, I think like if you wanted to run a web server that the image runs port 80, but you want it on 8080, you would instead, when you're running it locally on your computer, you would do -p 8080:80, if that makes sense. The next option that's new here is the -v option, and it's a little advanced, but it's super useful. So it's well worth knowing and understanding what this does. And all it's doing is it's saying, I want to take this folder on my local computer and I want it to be mounted inside of the container at this location. This will allow you, in our case here, what we're doing is we're basically saying, whenever the MongoDB is trying to talk to its own database, whether it's creating a database, updating, whatever, it's going to store all its data in the /data/db folder inside its own image. Well, we're mounting into that, so it's actually going to be writing to our local directory, our local folder in the var temp folder. And this way, if we decide to delete the container or we have to update to a new version of Mongo so we lose that container, when we spin up a new container and do the same thing, mount that same folder, we have all that data in there. We get this persistence across runs, across images, across containers. So it's a great option to know because anytime you run databases or anything that you need to persist data, you can store it on your computer and have it forever, as opposed to running it in a container where once the container gets deleted, you'll lose everything inside that container. And the last option, the -d, that just tells Docker, when you run this, immediately detach and run it in daemon mode. So it's basically just going to start the process and then exit out, and it's now running in the background, so you won't see any of the logs. Lastly, it's worth noting that we specified the image with a tag after it. That's how we see Mongo:8. That 8 is a tag. If you go to Docker Hub, you can see all the available tags that are available for a particular image repository, which in this case is Mongo. This allows that repository to host a whole bunch of different images, and each different image is a separate version. In our case, we want the the most recent version that's under the 8 major version. They have a whole bunch of other versions you could choose from, and usually the Docker Hub website will explain what the different versions are and recommend what to pick from. So once we run this command and we drop back down to a command line, we can run docker container list again, and we see that MongoDB is running now as a container with the name mymongo. If you ever want to see the logs from your container, you can type in docker container logs and then the name of your container, in our case, mymongo, and it'll print out the logs from that container. So now that it's running, I can connect to Mongo through the command line, also using Mongo. I've already downloaded that image using Docker, so now what I could do is I can give it a different set of arguments, and this will allow me to connect to the locally running MongoDB and access it through the Mongo SH, which is the command line way to access MongoDB. So you can see here there's another set of arguments that are different than the one we ran previously. The -it is telling it to run in interactive mode, that's the I, and to emulate a terminal, which is a T, and that will allow us to be able to type commands and get back results. So anytime you plan on interacting with a Docker command through the keyboard, you might want to include the -it flag. --rm is telling it that we don't want to actually save this container. So once the container finishes, it exits, then it'll be automatically removed from the container list. We don't have to go back and manually delete it ourselves. And the --network part is a more advanced feature, but it's basically saying that we want to actually connect to the container that's named mymongo and talk to its network directly. So this way we can actually access that port without going through any other hoops in order to get the two different containers to talk to each other. And then lastly, you'll see that after we specified the repository, we added some additional arguments. This is what's going to be passed over to the Docker image to actually run a different command. We're not actually running the server now. Instead, we're saying, don't run the server, run Mongo SH with these arguments after it. And that's what it's going to run to get us to the CLI. So we run that and we can see it connects to the CLI. It connects to the MongoDB through the CLI. And now we could type in commands and access the MongoDB without any problems. So now let's exit out of the CLI and go ahead and stop the running container. And to do that, we use docker stop and the container name. Not the image name, the container name. So it'll be mymongo. So do docker stop mymongo, and then that will actually stop the running instance of MongoDB in that specific container. And if I go and look at the container list, you'll see it's not running. If I do a -a, it shows it in a stopped state. That means it's shut down. What's nice is you only need to run the docker run command one time. And now if you want to load back up your MongoDB instance, all you type in is docker start mymongo. And now the MongoDB is running again. This is why it's great for being able to have databases and maybe even different types of databases. Maybe you have, a Postgres database for one application and maybe a different Postgres database for a second application, a MongoDB for a third application. You can have all of these things as separate containers that you only start when you're working on the application that you have to worry about. Okay, so now you know the basics of how to run images and how to manage your containers. Well, how do you make your own images? That's also pretty easy. The way you build an image is by creating a Docker file. A Docker file is going to tell Docker how to package up the files that go into the image and what instructions need to go in there as well. For our example, we're going to package up a static site into the Apache web server. So to do that, we have to pick a folder that has the files that we're going to store everything in. And then in that folder, we create our Docker file. And in our Docker file, we're going to say that we're going to start with a base image. And in this case, we're starting with the base image of HTTPD, which is the Apache web server. It already has everything we need in order to run a web server, run the Apache web server, get it started, run it on a port, etc. So we're going to start with that. Then we're going to use the copy command, and that's telling it, take the files that are on our hard drive, on our computer, and copy it over into the image at the specified location. So we're saying copy from here to here. And that's it. We just copied our HTML files over into the web server's public HTML folder. And now, if we go ahead and save this, we can actually build the image using Docker's built-in commands. And that is docker build. The syntax for docker build is pretty simple. In our case, we're using -t, telling it tag the image that we create with this name. I'm just calling it site with a dev tag after it. And then you have to specify a folder where the contents of everything exists. In our case, I'm just doing a dot for the current folder. So I hit enter, and the image is built. So when I type in Docker images, it shows that my site dev image is available locally to use. And then if we run this image as a container with the port 80 port exposed, you can see that now when I go and visit localhost 8080, the files that I put into the image, the ones that I loaded in, are the ones that show up in the web server. This is a common pattern you'll see where as part of like your CI/CD process for your application, you get the pre-built files. Like in our case, it's pre-bundled, pre-built, CSS, JavaScript, HTML. If it's a Java application, it might be jar files. If it's Next.js, it might just be the contents of the dist folder. Whatever it happens to be, it's going to take those built files, it's going to add that into a base image like, again, Next.js or Apache or whatever it needs to be. Now, there are plenty of other directives you can put into a Docker file. I showed you from in copy, but there's other ones like if you do run, you can actually run specific commands inside of there as part, as if you're actually inside the image. So that's a way to, maybe your base image is Ubuntu and you want to install additional packages. There are directives to specify environment variables that are included in the image. There's ways to tell it what programs to actually run on, when you run the image. All of these different options are available and well documented on the Docker website. So I recommend reading through that. Another great way to learn about how Docker images are built is to use the Docker history command. You can take any image that you can download to your computer. So any image basically from Docker Hub, for instance, and you can do Docker history and then the image name, and it'll actually tell you all the different commands that were run to get to the point where you had the final image. So a great way to learn is just pick random images and type in Docker history and see how they were built. So there you go. That is Docker in a nutshell. Those are the commands you're going to need to know as a developer to get work done more efficiently day to day. I hope this helped you out. If you have any questions or feedback, let me know in the comments below. If you do me a favor, hit that subscribe button. That would help me out a lot. And as always, thanks for watching, and I'll see you next time.